So I'm Phil Drake. I'm the CEO and co-founder of pgEdge. And we talk about use cases that optimize the distributed Postgres. And pgEdge, in fact, guess what? They bring up distributed Postgres. Now, as we do a bit of sonic and sifting here, like, wait, I wanted to go somewhere else. That's fine. No thanks. My colleague Jan P. was speaking before lunch talking about how undesirable the squat after lunches. So thank you for very invitation. He makes claims that people are just getting really sleepy, notice had a big lunch. So I organized for a couple of minutes with espresso before eating. You have to wait for 20 minutes. Is that good? Coincidentally, with my talk. All right, so it happens. I'm like a serious, because I'll stay. 5 minutes. That is better. Think about me, someone who about my background, although I've been a CEO for quite too long and had a technical sense big outings. Once upon a time, blanking web services and web APIs are chemical web methods, and then went on and co-founded Enterprise DB, with my good friend Dennis who was here, and then Yasta, and Des is back up to 200K, and so 2 years ago we co-founded pgEdge to go after the distributed Postgres problem. I'm going to talk about today what we see as the drivers to it. Why I like to do distributed Postgres? But why would you actually want to do this? Because the pg.white is sitting in straightforward and has single instance Postgres or an active passive cluster. So why? And then that's the first part of this, and really the use case this one, right? In a little bit more detail, those drivers as to what a way to kind of spend time on this. And I was going to do a quick dive. The CEO actually got demos, but we're rich all the time, and it's always advice-y. So think about today's applications. Applications that they view are responsible for supporting the house. They need to be always on, always available. People's callings for downtime has evaporated, and in many applications, particularly in financial services, and for the important arenas in the Christopher Comtolian and area, and increasingly you have to set up a global user base. Your users to be in the world, even if they're inside applications. And you might also have to deal with the residency requirements, right? European data needs to stay in Europe. Saudi Arabia has particular concerns around data sovereignty, and so on. And so what we ask the distributed Postgres is an effective way of meeting these demands. Quick term on our product, built on an asynchronous logical replication with conflict resolution and conflict-free delta columns. What that means is for running sums where last commit wins approach doesn't work for conflict resolution. You actually need to take the deltas from the multiple nodes and apply them together so you actually get the right hands on them. So we've got that built in. We've done a way to enhance this enhanced electrical replication to greater fault tolerance for us with support for high availability. Now, some of you might know that in distributed databases, there's this thing called the CAT theorem. CAT being consistency, availability, partition tolerance, and because of the laws of physics, you get to pick the center. If geographic distribution isn't one to you, then you have to pick availability over consistency. So we have a functional consistency, and that allows us to do asynchronous because speed of light is actually a thing, and synchronous write. We got one customer who's got a cluster that spans Cape Town, Sydney, and Oregon, and you don't want to consider what it takes to do a synchronous update across all of that. Yes. So at this point, we've been in the market for a bit over a year, and we're working with some fantastic customers, from the European Parliament to America's National Security Agency, Government in Germany, all choosing pgEdge for mission critical applications. So let's talk about these use cases. Oops. The first one is low latency for both reads and writes. So in multi-master, we're making copies of the database that are kept in sync, and you can take reads and writes at each of those nodes. And so that means you've got the data closer to where you use this, having to be located, wherever they're located. And it turns out that in a 3 or a 5 node cluster, with good selection of the region was matching up with your workload where you use about, that actually turns out to be a really good solution and gets latency down for all users on a very consistent basis. So we've got a customer, for instance, who has an AI inference application, and the biggest customers are in Japan, but they were hosting out of East Coast, and they were seeing 7-second response times, which just wasn't acceptable for that application. So the first thing you could do with multi-master distributed Postgres is you can solve that latency problem. Next up, ultra-high availability. So if you think about it, if you've got multiple copies of the database around the geographic network, you can lose one of those nodes. And we used to say, hey, one of those nodes have been used, and then go and mention security costs who actually care. There's things to collect, list that on. But you can obviously lose one of nodes, and the traffic just routes to the surviving nodes. And we do that in our third product, just using latency-based route in DNS. So latency-based routing, you lose a node, and you just have the traffic automatically extract over to the next nearest node. Data residency, talk about these in a bit more detail in geographic scale. There are products in the market that have been doing this for quite some time in the legacy database world. In particular, Oracle Global Data. Oracle, if we have any new from Oracle. Oracle has a tendency to charge a king's ransom or queen's ransom for this capability. We know of financial services institutions and other big companies that are literally paying into the tens of millions of dollars in Oracle licensing. And so the CIO is that for some odd reason they're kind of keen to get off it. But they've, in many cases, already started down the path of everything like, no stress migration, already chosen Postgres as where they want to go. But Golden Gate has been holding it back. And so with this capability, we can now say, well, look, some of those applications you've still got stuck. Tom Waits said there, but should now be migrating. I think you get the basic idea with latency. You've got European users, users in Asia Pac, and if you're hosting out of US East Region 1 on AWS, which everybody's default choice, which have to be a Google or Microsoft, in case you're using their Eastern region, US, Lord data centers at Larkin County, let's start with. That is going to mean that your page load time while you're out, whatever your eyes are happening to do, whatever you measure response time by, you just kind of see not great performance to bring in where you get from where your application logic and database hours. And if you want to take advantage of something you which platforms like collection workers or word selling, which do a great job allowing you to distribute your application logic around the world. If you've got 200 milliseconds round trip back to the database, it kind of fits the purpose because that platform in the first place. High availability. Just by the nature of this architecture, you've got that built in and always coming late. But what a lot of our customers want to do is they want to marry that up with running replicas for availability funds. And so we've been doing some work to match synchronous replication across availability zones with our asynchronous replication across regions. And our physical engineer working on Brian is here at the conference, and he's giving up 1 but 3 talks on the different aspects of what that involves. So we'll let the CEO for the detail on that, give it one of the guys' talks. We'll let you know. This thing working. Now, this idea of data residency, who has actually encountered this as a requirement in the applications they have to support? I'm seeing some dogs with heads up hands, right? It's a pretty standard code. And at the last couple of SaaS companies I ran, you place this, and it didn't matter, and I'm inclined to explain to your customers that GDPR doesn't say that the data has to reside in code. They want the data, remote, but. And then increasingly, you've got these data sovereignty laws in different jurisdictions around the world that require data to not just reside there, also in process there. So to respond to that, and so what we do, the SaaS company I worked at, we just simply stood up a completely redundant application stack in each of those locations, start, you're done, which is just not ideal. So in bed as CEO of the company, I'm like, well, how can I get a little picture of what's going to be fun with that customers? Because we just created a whole bunch of IT development, right? So the way our site says it has some global architecture with a global data where you're able to say, this data, I want to be replicated, I want replicated globally. And that could be things like aggregated all our data through a point, which is what people do in the thing when they move these architectures. And then the actual customer data and then all the data, general orders, and they're all digitally course trail. You can keep all of that in contributor. So because we have built into our architecture a capability for selective replication, so you can say this table and this table will be replicated, but these tables, they stay local, the local bag stays local. Or you can do it by filtering rows or by partition, so a lot of flexibility. So that gives you an architectural tool set to go address this at the gateway stimuli and not do something that is really going to cost you big time in maintenance down track. And things like wait, by sitting on spread measure stacks. And a final one on a geographic scale. So when you focus as their application at scale to some pretty tremendous volumes and processing, that they start to get over things the limits of Postgres. And sometimes you get to that point where it's like, we don't even buy bigger servers, hosted by cloud provider, but for our own on-prem infrastructure. Yes, you've got workloads where you've got users around the world, and there's some locality to the workloads, like so users the Asia Pac, and that data is going to stay in Asia Pac. And there's not much interaction there in Europe with the European zones and North America. If your workload breaks down that way, you can look at using the suite of Postgres and synchronous replication to allow you to have that federated code system, but the workloads for each region get processed in each region. And that means that you're able to get part state on full-screen window on processing and bagging with the stand Postgres architecture. And then you also get the latency, the injector that's all right. There's customers that come to us, and it's actually not I think everyone's got this, it's not being just one of these benefits that they're looking for. It's usually a combination, latency, high availability, which turn out exactly nothing. It's to be two sides in the same coin. Or you can just go high availability, or that means for solution data residency, but typically it's some combination of both these. So, I've been talking exclusively about the database, but really don't think about the applications that. Because if you want to solve, well, certainly if you want to solve the latency problem, will the data residency role, you've got to consider the whole application in total. So, what are you going to do with the application? Well, you know it as well. But guess what? It turns out that nobody is here. So replicate an application logic that it is data with databases. And so it's relatively straightforward. Particularly if you've got pretty automated built-in point process and CI/CD pipelines, will just spit out redundant copies to different regions. I will say that if you don't have fully automated CI/CD pipeline management lists, you definitely want to consider getting down Plagus before going into multiple regions, because if you're doing things manually in just one region right now, that's probably not going to scale as a distributed around the world. A couple of other considerations. Postgres is open source. If you really do distributed Postgres, I think you want to go distributed Postgres solution via open source. We are, in fact, open source, although I should say it's in lowercase s, so we don't control with the OSI licensing list. Our license actually allows customers to do anything they want without code, except directly agreements. Which I think they have a lot of company told us they got to that all. So open versus proprietary, and then I don't want to have too much with the competitors, but there are so many companies in the distributed database space that have fine technology, great NoSQL distributed databases, but they call themselves Postgres. What does that actually mean? For your application, it might be that you've got a very straightforward kind of application and add tons over, but most applications are like that. And if you want to stay in a Postgres ecosystem with access to all the extensions and all the tooling and all the developer skills, that should be a big consideration versus going to one of these mono-vendor Postgres compatible solutions. All right, so multi-master distributed Postgres, strong technical solution for each of these use cases. We are just outside. Oh no, actually, we're I just realized down floor. So we've got a table upstairs, all the way in the back. And we've got some cool t-shirts, and then I want to encourage you to see the guys' limitations on ultra-high availability if you want to delve deeply into that topic. And so that gets us to just about time where this reinformating questions do. Yes.
How do we have like I think it'd be best for it's one big CDN.
So there's a question, how do we handle conflicts?
Yeah.
Yeah. So we have a conflict resolution algorithm, which is configurable. And so you can set that to work off of commit timestamps. So earliest commit timestamp wins or last commit timestamp wins. You can say, I've got multiple master meetings, but this one commit is more of a master than the other ones, and so whenever there's an update from this node, that's 6 precedence. So a few different rules like that. And then as I was saying earlier, for things like aggregates, running sums, that you need this idea of conflict is bringing the data types. We've implemented these lightly conflict-free delta by columns, where you simply say, this column is aligned to sum, and we'll make sure that the system actually gets the deltas from each of the nodes. 2, possibly more, typically 2, and make sure that both of those get applied. So in that instance, everybody's favorite example for this is the standard banking application. I'm taking money out here in the US, $200 out of ATM. My wife takes $300 out in Europe. Last commit wins doesn't work for that. You actually want to get the 200 and 300 and deduct 500 from the account. That's how that looks. Okay. All right. More questions outside. All right. Thank you very much.